Hello everyone. In this video, I'm going to discuss about DC to DC converter, buck boost converter type. So it is a combination of buck and boost. It can step up or step down. Step up and down, up or down the voltage. V out can be increased or V out can be decreased. This one is V source. This one is V out. So we can increase the output voltage or we can decrease the output voltage. Okay. Buck boost converter consists of switch, diode, inductor, and capacitor. Same as the buck converter and also boost converter. Just in terms of arrangement of switch, diode, and inductor. Okay, so we will analyze in two sections during switch on or during switch off. This is control of full period time. Okay, switch, we will use a semiconductor switch. To control on and off the input. So this switch will control on and off. Then the timing, time on and time off, the controlling of time on and off will produce our desired voltage, V out, desired voltage. Okay, whether we want increase or we want to decrease the output is determined by the controlling of semiconductor switch. Okay, this switch. So we will start to analyze one by one. Start from switch on and turn off. Okay, first during switch on time. Okay, this switch we on means that we will short circuit this switch. So when this short circuit here, okay, look at this diode. This diode, position of diode like this. So when the current flow here, inflow, so this diode will be reverse bias. So open circuit. This diode will open circuit like this. So all the current will flow pass through inductor and go to Vin or Vs. Okay, they will circulate in this loop only due to open circuit at this diode. So we can see that it look like this diode, this portion will be removed, will be split from the first loop. Okay, so we can draw it again. So the circuit will be like this. Okay, Vs plus minus Vl. This is inductor. This one is In. Okay, IL is here. RL. Alright. So when we do KVL here, KVL minus Vs plus Vl equal to 0. So that means Vl equal to Vs. Okay, during time on, Vl equal to Vs. Okay, let's say this is our Vs. This is our Vs. So at this part, this position, during turn on, Vl will be equal to Vs. This is Vs. Okay. Vl equal to Vs. Okay, Vs. Next is what is IL. Okay, we know that the characteristic of inductor will charging, store energy. So RL will increase gradually. Okay, due to charging of the inductor. So IL will increase gradually. Let's say this is our IL. I will increase gradually. This part we call IL minimum. This part we call IL maximum. Maximum. It will charge up to this maximum. Okay, during T on. Okay, still during T on. We charge up to maximum. Okay, next ID. Okay, what is ID? We know that this diode is open circuit. So means that ID equal to 0 due to diode open circuit. Okay, ID is here. ID is 0 during T on. Okay, during T on, ID 0. Next, what is IC? Okay, from this point, KCL here, this is ID, this is IC, IC. Okay, IC, IC, ID. ID is this direction due to you look at this the arrow of diode like this, so means the ID will be go to the left. Yeah. So we do KCL here. KCL I. So all the current go out to the loop. Means that ID. Sorry, all the current go out from this point. So ID plus IC plus I not equal to 0. ID is 0 due to open circuit. So IC equal to IC will be equal to minus I naught. Okay, in this case is I naught is here, is I desired. So IC will be negative I naught. Alright. Okay, that one is during switch on. Okay, next we study the waveform, the response during switch off. T off. Okay, at this part. So during switch off, we open this switch off. Okay, this will be off. Alright. So what happened? What happened is it look like this part will be removed, split. So we only have this part only. Okay, let's draw it. Okay, diode, capacitor, resistor. V out is here. BL. This is inductor. Okay, IC. I not. Okay, plus minus V out. Alright. So previously during T on, we know that the inductor will charging during T on. Now during T off, when we remove the switch, what happens is the energy that stored in this inductor will discharge. The energy discharge. Okay, so it means that you will release current will flow. Let me change. Okay, current will flow, air will flow through the circuit and go here, go here, go here. So this diode will be forward bias. So it will short circuit. Okay, forward bias short circuit. Alright. This is ID. Diode current. IC. Okay. Okay. current will flow, will supply. Means that the current from the energy from inductor will supply the current to the circuit, to the output, and also to the capacitor. So complete circuit. Okay, we do KVL here. Okay, right. Plus VL minus V naught equal to 0. Okay, VL equal to V naught. Okay, we can see that the current is flow from bottom. So means that the terminal will be positive. Okay, positive, and this terminal will be negative. Okay, flow of current is from bottom. So we have to change the polarity of voltage. Will be like this. So VL will be minus V naught. Okay, plus VL plus V naught equal to 0. So VL will be minus V naught. So it's based over VL here. So minus V naught, let's say here, minus V naught. So during switch off, so VL is equal to minus V naught at the bottom. Okay, how about the current IL? Okay, IL is release energy, or it will decrease gradually. So it will decrease gradually from maximum to minimum. Okay, due to discharge the energy. Okay. How about the ID? Okay, we can see that IL is here. Here is IL. ID also here. So means that ID is equal to IL. ID is equal to IL from the same line. Okay, same line. ID is IL. ID here. So ID is equal to IL. So we just follow the angle of IL. So IL like that. So that's my ID will be like this. Okay. ID equal to IL. IL decrease, ID also decrease, same slope. Okay, just previously from here, from 0. Next is IC. Okay, where is IC? IC is here. Okay, JCL at this point. Now IC will go up. I not also go up. So IC plus I naught equal to ID. So that means IC equal to ID minus I naught. Alright. So let's say this is our ID. This is our I naught. So that means it will shift 1 like this. ID minus I naught. Okay. At this point, ID is equal to I naught. So at this point means that IC equal to 0. It's fine. It's equal to 0. So just follow same slope. You will be like this. Okay. Okay. Alright. Now let's guarantee off. Then when on again, so just repeat this session. So like this. Same. About this. Okay, same. Just repeat this one. Okay. This one. Okay, doing both. Then off. Okay, repeat this session. bottom. Okay, so will be plus Is minus V naught, then plus Vs minus V naught, plus Vs minus V naught. Okay, for that, increase, decrease, increase, decrease, increase, decrease. So this one go up, decrease, go up, decrease. Okay, so with this one too. Okay, look at capacitor. We know that capacitor it will charging and discharging. So when current flow through the capacitor, this capacitor will charging up to maximum. So capacitor will charging and discharging, charging, discharging. So this one is maximum charging. Okay, we can see that. Okay, this part is charging. It will charging during off. Okay, during off it will receive current from IL. This IL. So it will receive current from IL during off switch. Means that this capacitor will charging during off switch. So here is charging until here maximum charging. So maximum charging means that the V out also maximum. Okay, because VC and V naught is parallel. So when VC maximum, V out also maximum. When VC is minimum, V out also minimum. Okay, this one is maximum, this one is minimum. So at this part is maximum charging. So this one at this part will be maximum V out. This part is discharging. Discharging here, minimum discharging is here. So like this. Just draw like this. Okay, just follow, repeat. Okay. So our graph of the V out, actual V out will be fluctuate like this due to ripple. Okay, this one we call ripple voltage. This one we call ripple current IL. Okay, this one is charging, discharging. This one is maximum V out. This one is minimum V out. Okay, that one is during off period. Okay, so total is T. Okay, next we will study how to calculate of each parameter. For example, L, C, and V out. Okay. Okay, next we want to calculate the parameter of V out. The question for V out, what is V out? Okay, we know that using volt second balance theorem. Okay, from volt balance second theorem, the total area during on and during off is equal to 0. So we can say that V on times T on plus V off times T off equal to 0. So during on, what is V during on? During on is V during on is Vs T on plus, so during off is here, off V is here, is minus V naught, T off equal to 0. Vs T on plus minus V out T off equal to 0. So Vs T on equal to V out T off. So the equation of V out will be V out equal to Vs T on over T off. Okay, we know that this is time T. So T equal to T on plus T off. T off equal to T minus T on. So substitute here. So we will get V out equal to Vs T on over T minus T on. Now we divide all by T. We get Vs T on per T 1 minus T on per T. Okay, we know that T on per T is equal to D, duty cycle. So finally, we will get V out equal to Vs D over 1 minus D. Okay, this is our output equation for the buck boost converter. So now we can arrange it. V out equal to Vs D over 1 minus D. Okay, for buck, we know that for buck, V out will be less than Vs. So this equation, we can say that to get V out minus V out less than Vs, D over 1 minus D should be less than 1. Okay, when less than 1, rearrange it. D less than 1 minus D, 2D less than 1, so D less than 0.5. Okay, D is less than 0.5. So means that for buck converter, D is less than 0.5, greater than 0. Okay, that's for buck. For boost converter, V out greater than Vs. So you know that for boost V out is greater than Vs. So this equation, from this equation, D over 1 minus D should be greater than 1. So when D over 1 minus D greater than 1, so it means that V out will be greater than Vs. So rearrange it. D equal to, greater than 1 minus D. So 2D greater than 1, D greater than half. Okay, D is greater than half. So for boost converter, D is between 0.5 greater than D but less than 1. Okay, that is for boost converter. This one is buck, this one is boost. Okay, this is the equation for V out equation. This one is V out equation. This one is a condition to get a boost buck converter. This one is a condition to get boost converter. D is greater than 0.5 and less than 1. This one is D is greater than 0, less than 0.5. Okay, that is to get the equation for our buck boost converter. Okay, next we will find the equation for capacitor and also inductor for C and L. Now we are going to derive the equation for inductor. Okay, we know that VL is equal to L di over dt. Okay, so we consider during switch on, during T on. Okay, we know that during switch on, VL equal to, during switch on here, VL equal to Vs. Okay, di equal to this one. Di equal to delta L, delta L. dt equal to T on. So we'll get so this one substitute into this equation. We put into the equation VL is equal to Vs, L di is equal to delta IL, dt equal to T on. So we arrange it T on equal to L delta IL over Vs. Question number 1. Okay, next is during switch off. Okay, during switch off here, during switch off, VL equal to minus V naught. Di equal to this one, decrease gradually. The current IL current decrease gradually, means that minus IL. dt equal to T off. Okay, dt equal to T off. So using this parameter, we substitute in this equation. VL is equal to minus V naught equal to L. Di is equal to minus IL over T off. So rearrange it, we get T off equal to L delta IL over V naught. Equation number 2. Okay. T is equal to T on plus T off. So T equal to equation number 1 plus number 2. Okay, T on plus T off. Now 1 is equal to L delta IL over Vs plus L delta IL over V naught. So we will get L delta IL 1 over Vs plus 1 over V naught equal to Vs plus V naught over Vs V naught. So now this is equal to T. So we get L equal to T Vs V naught over delta I Vs plus V naught. Okay, this is the equation for inductor. Our buck and boost converter. Alright. Next, we will derive the equation for capacitor. Okay. Okay, next we derive the equation for capacitor. Okay, we know that charge is equal to C times V. So changes of charge equal to C times changes of V. Okay, change of charge is, we know that the change of charge is equal to charging time or discharging time. So we can get from this area This is discharging time. What is discharging time? Discharging time equal to this area. This area is equal to I naught times T on. Okay, so discharging changes of charge equal to area. This area equal to I naught times T on. Okay, also equal to this one C delta V. I naught T on equal to C delta V. So just arrange it. We call capacitor equal to I naught T on over delta V. Alright, this is the equation for capacitor of our buck and boost converter. Okay, that's all for the derivation of the equation of a buck boost converter. How do we derive inductor, get the inductor, to get a capacitor, and also V out. V out for buck and also for boost. They are the condition for buck and boost. Okay, I think that's all. Thank you. Bye bye. See you later.